In this video, we're going to take a look at Python's arithmetic operators. And here we have a table that just shows the operator symbols, sample algebraic expressions containing those operators, and sample Python expressions as well. So as you can see, we can do addition, subtraction, multiplication. Multiplication uses an asterisk character as opposed to the center dot operator, which doesn't appear on your keyboard. Exponentiation in Python is done with 2 asterisks side by side, so we'll demonstrate that in just a moment. And we have 2 different types of division in Python. We have true division, which always results in a floating point number, and we also have floor division, which gives back a whole number result. So we'll demonstrate both of those. And then finally we have the remainder, or what's sometimes called the modulo operator, which is going to give you the remainder after you perform a division. So I've now switched back over to my terminal window for interactive IPython mode, and in general we're going to start a new IPython session for each new video that we create. That will not always be the case, especially as we get into some of the later lessons that have more elaborate tasks being performed. But for the purpose of these first early lessons, we will typically work with a new IPython session each time. So remember, you can type Control-D to exit your IPython session and go ahead and terminate that. I'm going to clear my screen here just so that I can get the prompt back at the top of the screen, and let's go ahead and re-enter IPython so we have snippet number 1 as the first snippet once again. Now we have again lots of different arithmetic operators. We've already demonstrated addition and subtraction, so I'm going to focus on the operators that we have not used as yet. So for example, if I'd like to do some multiplication, I can take a couple of values, in this case the integers 7 and 4, and separate them with the asterisk operator, and of course you get the result of 28 when you press enter to evaluate that expression. Now, a nice feature of Python that we don't have in a lot of the C-based languages is the exponentiation operator. So the expression that you're seeing here is going to raise the value 2 to the 10th power, and that's going to give you the result 1024. Now, you can use the exponentiation operator with whole number exponents, but you can also use it with fractional exponents as well. So for example, if you wanted to take the square root of 9, you can do 1/2. I can't type today. There we go. You can raise 9 to the power of 1/2, and that will go ahead and give you the square root of 9, which is of course 3. And I didn't have to do 1 divided by 2. I also could have done 0.5, and that would work as well. Now, I mentioned that there's a couple of different types of division. You have true division, which is going to divide a numerator by a denominator and always give you a floating point result. And then you also have floor division, which when you divide a numerator by a denominator gives you back the highest integer value that is not greater than the result. So let's talk about and demonstrate those two concepts. So we'll start with the true division operator. So let's say, for example, that we want to divide 7 by 4. In Python, the division operator is a / character, the true division operator, I should say. And of course, 7 divided by 4, 4 does not go into 7 a whole number of times, so we're going to get a floating point result. And even if it did go in a whole number of times, the result would just have 0.0 at the end. So here we have 1.75 as the result of the true division. Now, if we do that same expression with floor division, what happens is it effectively truncates the floating point part of a positive number and gives you the again the highest integer value that is not greater than the result. So the result with regular division is 1.75, so the highest integer value that's not greater than dividing 7 by 4, which gives you 1.75 normally, is going to be the value 1, and you can see we get the whole number 1 as a result out of that. If I divide a number by a denominator that's bigger than the numerator, in this case you're going to get 0 as the result, because there's only a floating point result of 3 divided by 5, and the biggest integer not greater than that result is the value 0 in that case. If I want to do something like 14 divided by 7, of course in this case you get a whole number of times that 7 goes into 14, so you get what you would expect in that case, which is the value 2. Now, when you're dealing with negative numbers, you may not get exactly what you expect based on what you just saw here. Again, you get in floor division the highest value not greater than the result. So let's take a look at what we get when we work with floating point when we work with negative numbers. So if I do true division for negative 13 divided by 4, we can see in true division the result is negative 3 1/4. If I do the same expression, remember you can use the up arrow key to recall a prior snippet, and in this case I'm going to go ahead and change this to the floor division operator, and in here you can see that the result is negative 4. So that may be a little bit of something that you don't really understand based on what's going on here, but again, largest value not greater than the result. So if we were to say negative 3 is actually a larger value than negative 3.25, so it actually gives you the largest value not greater than that, which is actually negative 4. So it's going down to the highest integer that is not greater than the value you would get with the true division operator. Now, Python does not allow division by 0. In some languages, when you divide by 0 in integer arithmetic, you get what is known as an exception. That's typical, for example, in Java and C# and some other languages. But when you do floating point arithmetic and you divide by 0, you get positive or negative infinity in a lot of languages. In Python, whenever you divide by 0, whether it's floating point arithmetic or integer arithmetic, you always get a division by 0 error. It's actually called a zero division error. So let's demonstrate that. So if I do 123 divided by 0 and press enter, what you're seeing here is the result of what's known as an exception that occurred. When an exception occurs in IPython interactive mode, it displays a traceback, which is what you're seeing here, that tells you the name of the error that occurred. It says that it's a traceback. It tells you and it shows you the snippet in which that error occurred. So that was the 123 divided by 0 from up above. It was line number 1 in that snippet. There's only one line in this particular snippet, but as you'll see in later lessons, sometimes we'll have multi-line snippets. And then it also rehashes the error name and gives you an error message, in this case indicating that we performed division by 0. Now there's lots of different exceptions that you're typically going to encounter, not only in your everyday Python programming, but as you learn the language as well. So for example, if you were to try to use a variable that does not actually exist in the IPython session, so let's say we did something like z plus 7, z is a variable that we have not defined yet. So if I go ahead and press enter, it gives me in this case a name error, which is a different type of exception. The vast majority of exceptions, by the way, have names that end with the word error. In this particular case, it's telling me that the name z has not been defined yet. So I would now know that maybe I didn't define the variable at all, or maybe I defined it with a different name and spelled it incorrectly. So that would be something to help me figure out what I did wrong. Let's go ahead and move on to the remainder operator. The remainder operator is going to perform division and give you the remainder after that division. So normally, if I divide 17 by 5, 5 goes into 17 3 times, and there's a remainder of 2 left over. So what I'm going to get out of this is that remainder value of 2. Now, a couple of notes about arithmetic before we move on to the next video, which is a self-check based on this section. First of all, you'll notice that all of the expressions that I wrote up above here are in what we call straight line form, meaning that they proceed left to right across the line of code that we're entering. There is no capability in Python to enter, for example, negative 13 divided by 4 in a format where the minus 13 is above a horizontal line and the 4 is below the horizontal line to represent a numerator and a denominator. Also, you can always use parentheses to group expressions to force order of evaluation, and we did show you that back in lesson 1, but let's just take a moment and say that we want to multiply the value 10 by the quantity 5 plus 3. So by using the grouping parentheses here to group together the operands 5 and 3 with the plus operator, this is going to force that expression to execute first. So 5 plus 3 gives me 8, and then we'll multiply that by 10, and if I hit enter, you can see the result of 80 in that case. And of course, if we do the same exact expression without the parentheses here, the operator precedence is going to take hold. Multiplication has higher precedence than addition. So in this case, we get 10 times 5, which is 50, and then we add the value 3 to that to get the result of 53. So as you would expect, you have precedence of the operators, which is very similar to what you have in regular arithmetic, in algebra, for example, and you have parentheses that you can always use to help you force order of evaluation, or just to help you clarify an expression if you would like.